take a look at another example of hypothesis testing. So the U.S. Bureau of Labor and Statistics reported that a person between the ages of 18 and 34 has had an average of 9.2 jobs. To see if this average is correct, a researcher selected a sample of 8 workers between the ages of 18 and 34 and asked how many different places they had worked. The results are given below. At alpha equals 0.05, can it be concluded that the mean is 9.2? So then we have this data here for these 8 people. We see the number of jobs was 8, 12, 15, 6, 1, 9, 13, and 2. Okay, so to begin our hypothesis testing, as usual, we need our hypotheses. So our first hypothesis, our null hypothesis, again, this is going to be a statement about a population parameter, and in this case, we're looking at means. So our mean in this case is going to be equal to 9.2. So if our sample is not any different than the whole population, it's 9.2. Our alternative hypothesis now is we're wondering, is it going to be different? Right, so we just asked, is this average correct or is it different from it? So that means that our mean is going to be not equal to 9.2. So from here we can know some things about the tests we want to do. So we want to look at one about means. We have a 1 sample. Next question we have is, do we have a known population standard deviation or not? Well, clearly we're not given the population standard deviation. So we have an unknown population standard deviation. And the last thing we could also indicate here is that this is a two-tailed test. So knowing these 3 things, we can now know that we should be using a t-test. So remember, t-test, we're looking at means, unknown population standard deviation for 1 sample, as opposed to a z-test in which we know the population standard deviation. So now if we go over to our calculator, and so we turn this on, we go over to stat. Okay. Now we are going to go over to the tests area and we go down to our t-test and we press enter. Now when we have our input, we have the choice of either entering data or we enter in stats. So far we've primarily been entering in statistics because we already have things calculated for us. But data, on the other hand, will allow us to go down and see that we can pull things from a list. And in this case, we could calculate the mean and the sample standard deviation using the calculator and then entering those in there from the stats, but we could just allow the calculator to do all of those steps for us. So if we go press the stat button again, we now want to go to edit. We have things in our list. We can go up top and clear it by pressing the clear button, then press enter. That goes away. And now we can enter in our data that we have. We have 8, 12, 15, 6, 1, 9, 13, and 2. So now that we have our data entered into L1, we go press the stat button again, and then we go over to our tests. We go down to the t-tests, press enter. And now when we go to our data option, indeed, we have our list, our data is entered into L1, that's good. Now mu sub 0, that's our null hypothesis, in this case it is 9.2. Now we go down to the frequency, all of these data values occurred just once, so we leave that as 1. Now our alternative hypothesis in this case is that it is not equal, so that's an easy choice, just pick the not equals. We go down and calculate this. So what we now see from this situation is we could pull out some numbers of interest for us. So one number that if we look at here is this x bar. We have 8.25. That means that the mean of these 8 values was 8.25. So we calculated an average of 8.25. Is that significantly different from 9.2? Well, that's what we're testing right now. So we pull out our test statistic. So our test statistic in this case, this should be a t-value. Our t-value is negative 0.53, say 1. Our p-value in this case is going to be 0.612. Now, this is a very, very large p-value. So normally things that are going to be less than 0.1 or even, 0.05 is obviously what we're shooting for, but if it's even less than 0.1, those are going to be pretty reasonable ones. Here, it doesn't really look like there's that much evidence at all, so that's why the p-value is going to be pretty large, because our sample mean of 8.25 is pretty close to 9.2, especially when our sample standard deviation is calculated as 5.06. So we now make our final statement here that since our p-value, which is equal to 0.612, is larger than 0.05, which is our alpha, we do not reject the null hypothesis. So we do not reject the null hypothesis. There is not sufficient, so there's not sufficient evidence to believe the mean is different than 9.2. So make sure that when you're going through these videos that you are practicing writing down these steps. This is going to be the work that I would expect to see on an exam question or on a quiz question when you're showing your work. So make sure that you have all of these key steps down, but in this case, hopefully you should feel pretty good about allowing the calculator to do most of this by hand, so we do not have to do anything extra of calculating the sample standard deviation and sample mean by hand. Oh, oopsies.